Hey everyone, welcome. We are diving straight into a super fast revision of the chemistry chapter Solutions. No fluff, just the key concepts and exam tricks you absolutely need to know to nail your tests. Let's get right to it. All right, here's the game plan. We'll kick things off with the basics, then jump into concentration and solubility. After that, we'll tackle Raoult's law, really get a grip on colligative properties, and wrap it all up with a lightning-fast revision. Ready? Let's go! First things first, let's lock down the absolute fundamentals. So what actually is a solution? Well, it's way simpler than you might think. Okay, here's a really easy way to remember this. Just think of a solution like a kingdom. The solvent, that's the king. The major component, it's the one that rules. And the solute is the subject, the minor part that gets added in. Simple, right? Now, check this out. This table shows all 9 possible types of solutions. And you're going to want to pay close attention to this because examiners love throwing table-based questions at you from this exact concept. You've got to know your examples, like soda water being a gas in a liquid, or alloys, which are solids dissolved in other solids. Okay, let's move on. And trust me, this next section is probably the most important one for your exams, especially when it comes to the math problems. We're talking about measuring concentration. First on our list is molarity. That's with a big M. It's all about the moles of solute per liter of the entire solution. And here's the key thing to remember. Because it's based on volume, it's totally sensitive to temperature. If the temperature changes, the volume can change, and so can the molarity. And that point about temperature, it's a huge deal. Seriously, if you're gearing up for your exams, you have got to master the numericals on molarity. It's a classic. A total favorite for the question centers. All right, next up is its cousin, molality. This one's with a lowercase m. Now listen closely. This is moles of solutes per kilogram of just the solvent. See the difference there? It's all about mass, not volume, which means it's completely independent of temperature. It doesn't care if it's hot or cold. And this slide just drives that point home. This is the big showdown, molarity versus molality. It's such a common exam question. Why? Because chemists often prefer molality for one simple reason. Since it's based on mass, its value stays constant no matter what the temperature is doing. Okay, time for a quick dive into solubility. This is all about how much stuff you can actually dissolve. We'll look at solids first and then gases. For solids, the rule of thumb is super simple. Give it some heat and it'll dissolve better. For most endothermic reactions, solubility just goes up with temperature. It's pretty intuitive. Now for gases, it's all about Henry's law. And the trick here is even easier. Crank up the pressure and more gas will dissolve. That's it. The partial pressure of the gas is directly proportional to how much of it dissolves. All right, let's move on to vapor pressure and the super important Raoult's law. This one's all about what happens when solutes kind of get in the way. Here's the trick for Raoult's law, and it's a simple one. You add a solute, the vapor pressure goes down. That's the main takeaway. Adding that solute always lowers the solution's vapor pressure. Okay, this next part is a huge deal for numerical problems, so listen up. We're talking about colligative properties, and the key thing here is that these properties only care about one thing, the number of solute particles, not their identity. So how on earth are you supposed to remember all 4 of these, especially when you're stressed out in an exam? Is there an easy way? Of course there is. Just remember this simple mnemonic, RLBF. You can think of it as Raju loves big family. Got it? So what does this little code stand for? Well, R is for the relative lowering of vapor pressure. B is for boiling point elevation, and both L and F here point to the same thing, freezing point depression. The 4th major colligative property you need to know, by the way, is osmotic pressure. And finally, we're hitting our last section, abnormal molar mass. This is all about putting it together with something called the Van Hoff factor. Let's wrap this up. This is where the Van Hoff factor, that little I, becomes your best friend. It's just a correction factor for electrolytes, when particles don't play by the rules. And the trick is so simple. If particles associate or team up, I is less than 1. If they dissociate or break apart, I is greater than 1. That's it. So if you need a one-line super revision, this is it. Just follow the chain. Concentration leads to solubility, which connects to Henry and Raoult's laws. From there, you get to your colligative properties. Remember, RLBF and osmosis, and you wrap it all up with the Van't Hoff factor, I. It's the whole chapter in one sentence. And to wrap up, let's look at the top exam trends from the last few years. This is what you really need to focus on. That molality versus molarity debate? For sure. Henry's law, Raoult's law? Absolutely. And see osmotic pressure on that list? That's that fourth colligative property. And of course, nail those numericals for all the colligative properties and the Van't Hoff factor. This is your study guide right here. All right, you've got the full toolkit now for a quick and powerful revision of solutions. So the big question is, looking at that list, which of these high-yield topics are you going to master first to lock in those marks?